Hello students, welcome to the practice session of the digital electronics. This is for electronics and even for electrical engineering students. And this is Ramesh. We are going to have the discussion of how to handle the questions of the digital logic in a accurate manner but in a very less time, but by using all shortcut techniques and all. So let us start the session without the waste of any time. Your time is also very precious. So focus on the shortcut techniques, basically how we can have those to handle the questions in a very less time, that too in an accurate manner. That is very important, time and accuracy for this entrance exam. So let us focus on first the logic minimization techniques. On that we are going to focus now. Logic minimization techniques, in that we can expect the questions of 3-4 type of questions. Those also how we can handle in an easy manner, we are going to check that. Is it okay? Right, let us start. Related to the XOR gate and XNOR gate, in the logic minimization techniques, you can expect a question. Even mixed with some other combinational circuits also, you can get the question from that. That's why for XOR gates and XNOR gates, let us start with a short technique of that. That is, you just focus on this point of X exclusive, like that. You write 4 times like that, X exclusive like that. Okay. Now here, X bar 1 0. Once you are writing like that, that order only you have to make in a reverse way. Sir, what is that, sir? You just look at this. For example, this order is like this, no? You make this one in this manner. Like here, X bar 1 0. That means when we are making like this, the order that only reverse in this manner, so that you can remember these things easy manner, because these all should be on our fingertips to handle related to these mixed combinational or sequential circuit questions. In that we are going to have such type of combination of the things. Then for these things you should not waste the time, no? That's why for that purpose we are going to do like that. Okay, here then X bar 1 0, you just make this one as a shift like that, and this one is also like this. That means you can say shik like this. Shik, yeah, that means the order is like that. X bar 1 0 shik, and again X bar 1 0 like that shik. So shik like that. Simply you can remember in this manner. Even for XNOR also you can do like that. For XNOR we can have XNOR like this. For this also you make X bar 1 0. For this, these two things you should make interchange like the shik like that 1 0, and these two should be changed like this X bar in this manner. So these two things should be made shik like that, and X bar X also should be made like that. So in this manner, XR related and XNOR related, any of the question if they are asking, when these are on our fingertips, you can make the question in a simple way. And one more thing is also there related to the XR to remember, because XR gate related questions you can expect. That's why we are saying this. X exclusive Y is there, like that. X exclusive Y, X exclusive Y. Here, if it is completely complemented or any single variable is complemented, it is going to become as XNOR. You should remember that in an easy manner. Total XOR expression is complemented, or any of the single variable in that if it is complemented, we can say that is nothing but the XNOR expression. And one more thing is also there, that is X exclusive Y. In that, if individually both are complemented individually, it will give the same expression X exclusive Y only. So these are the things that you have to remember related to the XOR and XNOR gates. Got it? So when these are having on our fingertips. Based on this, the questions can be handled easily. Now come to the another point. Without the waste of time, I'm saying all the tips related to that as a summarized points of the short tricks. Based on that also we are going to handle the questions. Okay, right. Now come to this particular next one. They will give one expression like boolean expression. If they are giving, see for example, they are giving some boolean expression f is equal to a bar b plus cd, something like that. This is actually includes the logic operations of the logic gates like that and operation, and here it is the or operation, and here it is the complementary not operation like that. So that is the SOP form, no? Exactly. It is the sum of product form. It is the sum of product form, no? Now, this expression, they are asking that the entire expression has to be implemented with the help of only NAND gates. By only NAND gates they are asking. Because as you know, NAND, NOR, these two are universal logic gates. So by using them, any of the logic gate can be implemented and any of the boolean expression also can be implemented. That's why these are the universal logic gates, no? Now they are giving the SOP expression like that. Now they are asking about implement that completely by the NAND gates or completely by the NOR gates. First we will check about the completely by NAND gates, how to do. For this one, so many techniques, so many ways they are going to do like that, but we are now going to have the discussion of very simple and short technique for this one. It is actually a secret point, but now we are revealing this one. Okay, now come to this point here. The steps involved here are, step 1 we have to make like this. In Hindi I am saying this one, this is bar bar karo, like this. That means yes, you have to do the double complementation. That is I am saying bar bar karo. Karo means do, like that. Okay, right. Next, step 2. Step 2 is going to be inner bar expand karo. Inner bar expand karo. Sir, then is it going to be simply over? Definitely, we'll check that. Okay, now carefully observe this one, that expression we are taking here, a bar b plus this is 3d. Now for this expression, the step 1 we are implementing bar bar karo. That means bar bar. That means double complementation only. I am saying that bar bar karo, do bar bar. That means double complementation, you do it. So when you are doing that, second step, inner bar expand karo. That means the inner bar has to be expanded. That means what we are going to get now, this is a bar b, this is 3d, here plus is going to become as dot, d more galla. So this is bar bar, again it is complemented. So 2 steps are over. Bar bar karo, that means we just made this is bar bar, and inner bar expand karo. That means this inner bar is expanded so that we got like a bar b bar dot cd bar, like. Okay, now it's over already. Sir, wait sir, see this is the NAND gate only, no? This is like a bar b, this is the NAND gate. CD, it is also the NAND gate, and again these are applied to the NAND gate. That's enough, completed. Sir, but here one more a bar is there, no? Yes, of course. Whenever any variable is there, it is having the bar. For that, use one more NAND gate to get the NOT operation. So we can get this one like this, the way by using another NAND gate a. This is going to become as a bar. So here 1, 2, 3, 4 NAND gates. With that it will be completed with 4 NAND gates. With 4 NAND gates we got it. That's enough. So any of the expression when they are giving, that one if they are asking like implement that completely by the NAND gates, then simply take that expression and apply those 2 steps of, number 1 step is bar bar karo, that means double complementation, and second step is nothing but inner bar expand karo. So like that we did and we got it. So simple way we can get it. Got that? In the same manner, even for the NOR gates also we can do that. But here one interesting twist point is there. That is, for the SOP, for the SOP form, NAND gates, by implementing the NAND gates to get the SOP form, for the SOP form, the implementation of that expression completely by NAND gates is simply you can apply like this the steps. Okay, because SOP is NAND friendly. Simply by applying these steps we can get it. But for the POS form, we can't get like that directly. Sir, then what to do, sir? Further the technique is there. That also we'll check it. Okay. See, for example, there is an expression of f is equal to a bar plus b dot c plus d is there. It is POS form. It is POS form. For the POS forms, we can't apply that step of bar karo, inner bar expand karo like that. You cannot apply like that directly. For that, what must be done there, you just make that one to get in the form of SOP. Then you apply these two steps. So how it can be? Among these two, any of the expression you take as a variable. For example, this is some variable x. And that we are having here same c plus d. Sir, that means you are considering this x as, yes my dear, I am considering that x as a bar plus b as x. Is exactly like that only I did. Now you apply that the same technique of bar karo, inner bar expand karo. That means double complementation you do it. Then inner bar you should make the expansion like applying the De Morgan law. So we are going to do that. So for that, first of all we had to expand. This means we are going to get xc plus xd. Now it became in the form of SOP. Now you do this one as double complementation like this. Then we are going to get xc, xd, and here bar. So it's going to be, so c is connected to this one to the NAND gate, and xd is connected to the NAND gate, and these two are connected again to the NAND gate like this. But x is there, no? Yes, my dear. For that x we are going to do separately here, no? X is there. So, but what to do, sir? The same thing. Previously what you did, the same thing we had to do, like that, those two steps only. Now also has to be implemented. So like we are going to have here this expression, no? For that one, a bar plus b, apply bar. So that it's going to be a bar dot b bar whole bar. That is nothing but a dot b bar whole bar. So it is nothing but a b bar. This is nothing but connected to the NAND. It is the x, and that expression, this x has to be connected here and here. So 1, 2, 3, 4 NAND gates. But for this b bar, we are in need of another, no? That's why this b is going to be b bar. So here 1, 2, 3, 4, 5 NAND gates required. 5 NAND gates required. So this is the way you can apply. Very simple. Check this one, what we did here. For the SOP expression, for the sum of product form expression, if they are asking that, implement that completely by NAND gates, then you just do that bar karo, inner bar expand karo. That means do the double complementation and expand the inner bar by applying the De Morgan law. If they are asking about the POS expression like this, then just make any one of the term in the form of a variable and get that in the form of sum of product form. Then again implement the same process and do that. Then it will be easy. Got it? Check that. Okay, right. So next we are going to have the discussion of the NOR gates also like that. These all are actually short techniques, my dear. We are revealing these techniques for you. Okay, right. Now let me discuss like that for the POS form also. F is equal to, we will have For example, a bar plus b dot c plus d is there. Sir, it is already discussed. No. Now they are asking about by using the NOR gates, for example. Or by using the NOR gates, yes, the same two steps you should implement, my dear. For this one, step 1. Step 1, you should apply the same thing like bar karo. Step 2, inner bar expand karo. Okay, then that expression is going to be like a bar plus b dot c plus d. When you are having, do the steps like this. This is bar. Then we are going to have a bar plus b, and this is c plus d, and this dot is going to become as plus here. So bar, and this is the thing. Oh, we got it now. The NOR gates like this, a bar, b, these are connected to the NOR gate, and c, d, these are connected to the NOR gate, and these two are connected to the another NOR gate. Or this a bar is there, no? Don't worry, my dear. You connect like this to this one, so that this a bar is there, like that. 4 NOR gates. By that we can get it. Got it, all of you? Got it? So, this is the way you can make it. Sir, POS form by the NOR gate directly we made it. No, yeah. Sir, but I got another doubt, sir. Here, doubt. Ask me, my dear, what is that? Sir, if it is a SOP form, they are asking implement that by using the NOR gates. Hey, I want to keep that one as a secret. No, sir, please reveal that also, sir. How we can make that one? Yes, my dear, we can do that. Yeah, we will check that also. Okay. For example, here f is equal to a bar b plus cd. This is the SOP form. You know that? Yes, sir. But they are asking this one by using NOR gates. Then what to do, sir? Very simple. Previously, what you did, one of the term you took as a variable, no? Like that, you can make that here also. So this particular term you take as variable. So x plus this is the cd. We got it. But it is not the POS form, no. My dear, you wait here. You apply here distributive law. The distributive law, it's so simple, no, that one. You see, this one is nothing but x plus c dot x plus d. Isn't it? Sir. Then it is nothing but the product of some form, no, POS. Yes, sir. Now you implement this one to this one, like the same technique of bar karo, inner bar expand karo, like that. The technique now. Got it? Yeah, then you do it. Then we are going to have x plus c here, x plus d here, and this is going to be bar, this is plus, and it's bar. So, sir, then we got NOR gates only, no, sir? Exactly the same, no, I am saying to you. So, this is x and c connected this one to the NOR gate, and x and d connected this one to the NOR gate, and these two are connected to the NOR gate like that. Sir, but this x is there, no? Alright, into, don't worry, we are going to make that also, no? How? See, check this one, x, what we assumed? Sir, x we assumed as a bar b, no, sir? Again, do for that also bar like that. Yes, sir. Yeah. Then do this one, my dear. Yes, sir. Then what you are going to get, tell me? A bar dot b bar whole bar. But this dot is going to become as here plus, no, now? Yes, sir. So this is a plus b bar. So that it is a b bar. This is NOR gate. And this is actually x. And that is only should be connected here and there. Sir, but for this b bar, sir, don't become that much innocent. You connect that one like this. So the b is going to become as b bar. So 1, 2, 3. 1, 2, 3, 4, 5. 5 NOR gates we are going to get. Got it? Yeah, simply like that. So, POS forms are NOR friendly gates. That's why when we are having POS form, directly that expression we have to do like bar karo, inner bar expand karo, those steps can be implemented directly. Okay. But if it is the SOP form, It is not NOR friendly, my dear. That's why you do. Take one of the term as the variable and make like this the way in the POS form. Then again you implement the same thing like that. Bar bar karo, inner bar, expand karo. Then you'll get easily. Got it? So that is the way. So I hope you followed these things, isn't it? There is so many of my students here. They are giving their response and messages like, "Sir, Samas ko log dekh rahe." Arey, all are now equal only, my dear, because all are in the tens. That's why let me reveal all these shortcuts, because in the classroom I said I promised them. I think not really promised. They feel like that I won't reveal these things to anyone except you, like that. That's why they are asking like, "Sir, all shortcuts you are revealing." No problem. All are our children only, no? Right. Now, let me discuss the points here. Okay, now, this is about one interesting and important topic from which you can get the questions. Okay, right. Next one is the SOP and POS form conversions related to that. There we are going to get the questions, made. So, they will give an SOP form, and from that expression, they are going to ask about POS. So POS forms in K-map. This is very, very important topic. POS forms in K-map. But for this one, a short technique is there, because POS forms in K-maps especially, so many students used to have the confusions about it. Not our MEDG students, because they know about this, but let me handle those also. POS forms, how to do that. Please don't apply your own logic. What Ramesh Sir said, those shortcut technique logics only, please implement it. You'll get the things without any confusion in a very, very clear clarity manner. Okay, let me discuss that. So, you understood, no? POS forms in K-maps for that. How to do that, okay. So, POS forms in K-maps. Let me handle that with the help of like this previous story only, with some questions like that based on that. See, there is a K-map. So, they are giving one question. This is A bar A, B bar, C bar, B bar, C, B, C, B, C bar. 0, 1, 3, 2, 4, 5, 7, 6. For example, they gave a question F equal to sigma small m 0, 1, 6, 7, my dear. They gave, this is the question and we have to solve that. Sir, it is so simple, sir. Here 0, 1, 6, 7. So I can make this one like this, so that I'll get the A bar, B bar. And I can make this group because Rab ne bana di jodi. He made like this the group, no sir. So that we can make this is as AB. So F is equal to A bar, B bar plus AB. Sir, I got SOP form, no sir. My dear, answers, all options are in POS forms. Now tell me what to do. Oh sir, the question they gave in the sigma small m SOP form, yes, but all options are in the POS form. That is unfair, sir. What unfair? Any logic also they can ask, no? That's why they gave the question like that. So then how to handle, sir? Very simple. Whenever they are giving the question like that, you please follow the technique of what I am saying. Please don't deviate from this technique. Okay. Otherwise, you'll get the confusion state you will be, and you'll get the wrong answers. Okay. So for that, 2 steps you should follow here. Number 1 step, the K-map should have 2 changes here. Number 1 step in the K-map. Step 1, interchange the operator. Interchange the operator. Dot plus these 2 operators should be interchanged. Is it, sir? Sir, where the dot all there, sir? Array, here dot is there, no, my dear. Dot, dot, dot. a dot like that, those should be interchanged as plus. And second important step for the K map is complement the individual variable. Sir, complement the individual variable. Yes, the K map itself has to be changed. Is very important thing you should remember. Okay. For that K map, you should apply these two changes, my dear. Okay, we will check that. Okay, right. Yes. Now, the K map has to be interchanged, my dear. This is also top secret. I'm revealing this one to you. These are the two steps you should apply for the K map, and the answer will be just like that. It will come in a very accurate manner. Okay, we'll check that. Let me draw the K map here. K map I'm just going to draw here. Yes. This is A bar A, B bar C bar, B bar C, B C, B C bar. 0, 1, 3, 2, 4, 5, 7, 6. Hey sir, what Ramesh Sir is doing? The same K map no Ramesh Sir again made. Hey, these students are not having any patience to complete this one, Ray. Let me complete, Ray. Then only you have to check, no? First, let me apply these two changes there. Then only you have to ask me, no? Oh, sir. Sorry, sir. It's okay. Now, let me consider that in the place of dot, I have to keep plus, 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 and plus here. Sir, I will also keep one plus here, sir. What you are doing? Is there any dot here that you are keeping plus there? Sorry, sir. It's okay. Leave it. Now, so first step is completed, my dear. What is that first step? Interchange the operator. In the place of dot, we kept the plus. Okay. Next step is complement the individual variable. Wherever bar is there, remove that bar. Wherever bar is not there, keep the bar there. Like that, you have to do that. Okay. Now, let me do that. So here, first of all, wherever bar is not there, with this yellow color, let me make it the bar. Here the bar, here the bar, 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 bar. Yeah, complement the individual variable, no. Now, white color bar, wherever it is there, just remove that bar, bar, star. Yes, like. Okay. You just make like that. Now, these two steps are over, my dear. Interchange the operator is over, and complement the individual variable is also over. These are the two steps you must and should implement it. So many times I said no deviation for this POS forms in K-map because it is almost a question that you can expect, that too important, and where the students used to get the confusions for this. That's why we are revealing that short technique also, that for the POS forms, this is the way you should follow, that these two steps should be done. Is it okay, my dear? Right. Very good, children, really. Now, after that, this sigma small m now has to be converted into pi capital M. Pi capital M max terms 0167 means it's going to be now 2, 3, 4, 5. Other numbers has to be written there. So 2, 3, 4, 5. So that here we are having 2, 3, 4, 5. See, Ramesh Sir is keeping zeros there. Are zeros only had to keep because these are the max terms, no? False min terms. That's why you should keep the zeros only there, no, my dear? Right. After doing that, you just make this one like this a group, this one as a group, because Rab ne bana di jodi. Now this one is going to become as A plus B bar, and this is going to become as A bar plus B. Sir, why you kept the plus, sir? Of course, because the operator is plus, that's why I'm keeping the plus, so that this is A plus B bar, and it's going to be A bar plus B, so that this is nothing but the POS form completed. This is the way you should handle the question. Got it? What we did? Simply the K-map, we made it initial itself, the changes in the K-map. Number one is interchanging the operator. Like dot and plus, these are interchanged. Number two, we just made the complementation of individual variable. like that individual variable is complemented, then that sigma small and min terms are converted into the max terms, and those things kept as zeros, and from that we got the expression. Is it clear? Check it. Right, this is also you can expect a very good important topic for the exams. Okay, next topic, let me have the discussion, which you are waiting for that, I know. Okay, that is essential prime implicant identification in the K-maps. Ah, sir, this is also very confusion point, sir, for us, isn't it? No, just simply what the technique that we are going to make it here, we'll check that. Are you ready for that? Right, come to this point. Let me consider an example here. Here, this is the 3 variable and this is the 4 variable K map like this. Sir, essential prime implicant also a promising question now, sir. Chintu, almost. Okay, that's why we are doing this one. Don't worry, these things will be joyful, enjoyable things, my dear. You can get so easily. Questions should be handled with so much of joyful mood. Then only you can get the answer easily. That to the logical things when they are present. What, sir? This tense no exam. Everyone will have that. Everyone will have that. But who is going to overcome that in a logic way and joyful, joyful way? They are going to get the success easily. Okay. Now come to the point here. This is the A bar A. This is B bar, C bar, B bar, C, B, C, B, C bar. What are you doing? Just examples, questions which previously asked, those I am taking. Okay. Yeah, in this, for example, there is a question is given, f is equal to sigma small m 1367. There is a question, and another thing, f equal to sigma small m. They give the question here 1567 11 12 13 15, like that question is given, and they are asking identify the essential prime implicants. First of all, let me identify the ones in the K map, then we can go for essential prime implicants. It is so easy if you know the root point of that topic. Let me consider here 1 3 6 7 we identified here, like that here 1 5 6 7 11 12 13 15, right? Now remember, my dear students, while you are solving the K map, always you should follow the solving of K map should be from higher order to the lower order. This is the way you should follow. Sir, higher order to the lower order means what, sir? Into first you should check for octet. If it is not able to get, we are not able to get, then go for the quad. Or that is also we are not getting, sir. Then you just go for the pair. If it is not even that also single one, you should take the min term of that. That is the way you should follow. Higher order grouping to the lower order grouping. In that manner we should follow. Is it okay? Right. Right. In this one, let me focus on that. Right. Here. This is a group which we are having. This is the A bar C, and this is a group we are going to get. This is AB. As you know, if you made this one as a group, it's going to be BC as redundant group. Yes, sir. Now here you come to the grouping of first higher order grouping, so that this is the quad from which we are going to get the BD. And if you make the grouping of these two, we are going to get this is A bar C bar D. A bar C bar D, A bar C bar D, and this one is going to be A bar B C, A bar B C. Okay, like that. This is going to be A C D, and it's going to be A B C bar, A B C bar. Now sir, what you made, sir? All possible groups I made it. Of course, here this BD is going to become as redundant. BD is going to become as redundant. Okay, right. Now let me handle the point here. Essential prime implicant to identify among the groups that we got, that group is going to become as essential prime implicant in which at least there is a single one which is uniquely grouped. Uniquely means which is having a chance of only one time grouping. Ramesh, in Hindi also say, okay. Essential prime implicant वो होता है जिसमें हमको कम से कम एक सिंगल वन ऐसा मिलना है कि उस ग्रुप में जो एक ही बार ग्रुप में जा सके और एक बार उसको ग्रुप्स में जाने का मौका उसको नहीं होना है. ऐसा एक वन अगर उस ग्रुप में है तो उसको हम बोलेंगे एसेंशियल प्राइम इंप्लिकेंट. Sir, explain with examples now, sir. That's why I made it here. Let me check that. I'm giving half minute time also to you check those. Okay, right. Let me check that. Yeah. This group I'm explaining now. Carefully observe these things, my dear. This particular group is going to become as essential prime implicant only. Why, sir? Now tell me, in this group how many ones are there? Sir, 2 ones are there, sir. 2 1 है ना sir वहाँ? हाँ. 2 1 में, for example, focus on this one. For example, this one here is able to get the group like this here, and it is also having the chance मौका है to this one, by this one से भी एक ग्रुप बनाने का मौका इसको है. That means this particular one is able to get the group by this one and by this one also. That means this one, based on that we cannot say it is an essential prime implicant, because वो one ऐसा रहा वो वहां भी ग्रुप बना रहा है और एक जगह भी ग्रुप बनाने का मौके में है वो. Able to understand? Okay, that means A1 इससे भी ग्रुप बना रहा है और A1 इससे भी ग्रुप बनाने का मौका उसको है. That means this one is able to get the group like this, and also this one can get the group by this one also. So this one is failed to say that particular pair as essential prime implicant. But now focus on this particular one. This one, based on this one we can say this is an essential prime implicant. Why? Because A1 ऐसा है कि ये केवल एक ही बार इससे ग्रुप बना रहा है और एक बार इस वन को दूसरे कोई वन से ग्रुप बनाने का मौका उसको नहीं है. Mention English also, right? This one is getting the chance of only one time grouping with this one, but this one is not having the chance of getting the grouping with other one. Only this one, say this particular single one is able to get the grouping with this one, but it is not having the chance of getting the grouping with another one. No, that means it is having the chance of only one time unique grouping. That's why it is said to be essential prime implicant. In the same manner, you observe this particular group, my dear. This particular group. In this group, this particular one is not eligible to say that group as essential prime implicant. Why? हाँ sir, समझ में आया sir. ये one इससे भी group बना रहा है. Yes. And by this also it can get the group. No sir. Yes. That means this one is able to get the grouping more than one time. No. Yes sir. That's why it is not Based on that, we cannot say it is essential prime implicant. But, my dear, you check this particular one. Based on this one, we can say this particular group as essential prime implicant. So, this is essential prime implicant. How? Based on what we are saying? Based on this one, it is able to get the grouping. That based on this one, we are saying it is essential prime implicant. Why? Because ये वन केवल इसी से ग्रुप बना रहा है और एक वन से इसको ग्रुप बनाने का मौका उसको नहीं है, इसलिए। गॉट इट सर? इसका मतलब आप पहले ये बोलिए सर, एसेंशियल प्राइम इम्प्लिकेंट का डेफिनेशन यू राइट वन टाइम सर। इट इज एग्जाम टाइम, नाउ वी आर लर्निंग द डेफिनेशंस माय डियर, वी आर डिस्कसिंग ऑल द क्वेश्चंस, नो द एग्जांपल्स बेस्ड यू कैन अंडरस्टैंड, नो। For the sake of students, you can write now one time what may happen. Okay, I'm writing that. Essential prime implicant. It is that group. Every group is known as prime implicant. It is, you should remember. Every possible group is nothing but prime implicant only. So it is that group, that prime implicant, which is having at least a single one, in such a way that having the chance of only one time grouping. One time grouping, in the sense we can write as unique grouping. Got it? So in all possible groups, in all prime implicants, the prime implicants you are saying, yes, this is also important point. All possible groups are known as prime implicants. In those prime implicants, some groups becomes as essential prime implicants, which are having at least a single one in such a way that should have the chance of only one time grouping, and more than one time grouping it should not have. Then based on that one, we will say it is the essential prime implicant. That means, now check this. In this particular group, based on this one, which is having the chance of only one time grouping, we said it is an essential prime implicant. And based on this particular one, this is treated as essential prime implicant because this one is also having the chance of only one time grouping now. In this group, this one can have the grouping of by this and by that also, no? अरे एक वन की कीमत तुम क्या जाने रमेश बाबू, एक वन के बारे में हम बात कर रहे हैं, वो वन ये है ये नहीं. We are saying about based on this one it is essential prime implicant, not based on this one, no. Oh sir, then I got it out. Why it is not essential prime implicant, sir? Why it is not essential prime implicant? It is not essential prime implicant because in these two ones, no single one is having the chance of only one time grouping. Every one is getting the grouping more than one time. You check it there. For example, this one is able to get the group this, and this one is able to get the group by this also. In the same manner, this one is able to get the grouping by that, and this one is able to get the grouping by that also. That's why the problem. Got it? Now, based on this knowledge, you tell me in this one, what are the essential prime implicants we got in that example? You please tell me. Your students are giving a response. Yeah, thank you for your response and good comments. Just make it this one as this one. What are the things that we can say? Tell me here. Yeah, this is the API because based on this one and based on this one we can say it is also API, and based on this one it is also treated as API, and based on this one it is treated as API. And redundant is nothing but what we can see. This is not API, not API. Why? Because in these four ones, one time they came into the group of the squad, and another time everyone is getting the grouping with the corresponding pairs. This one is getting the group by this and in the quad also. Like that, this one is getting the group by this pair and in this quad also. This one is getting the group in this quad and by this pair also. And this one is also in the quad and by this pair also. That means they are getting like that the grouping more than one time. One time they are in the quad getting the group, and another time each one is paired with another one. That's why that particular quad is not eligible to treat that one as essential prime implicant. It is only prime implicant. Got it? Right. Yeah, so many students they are giving the reply like 4. Very good. Very good. Right. Now, let me focus like that related to the combination circuits in the multiplexer related also you'll get the questions. Sir, multiplexer questions, yes, it is almost you will get every year. Without multiplexer, there is no question paper like that it is. That's related to the multiplexer, how to handle the question, which shortcut technique I'll say that, carefully check this. For example, F equal to sigma small m, they are saying that 0, 1, 5, 6 they gave, and they are asking implement that by using 4 by 1 marks. 4 by 1 marks. It can have short techniques. For this one, carefully observe how we are doing this one. This is say I0, I1, I2, I3. Here they gave B, C, and here this is the 4 by 1 marks here. And like this, they can also give the expression in this manner, like this is AB, and C is used at the input. I3, you can say I0, I1, I2, I3, any of the way you can make it. Four by 1 marks. Here one very important thing is that function is f of ABC. A is playing the role of MSB. C is playing the role of LSB. So MSB, LSB point wise you should be very careful when you are applying a shortcut technique. When they give here BC, when they are giving here BC, that means the input they are using as, at the input they are using A. A means what? MSB they are using as input here. And here when they are using AB, at the input C they are using as input, that is LSB. So when the question is given, please carefully check whether they are asking the BC, whether keeping here select lines BC or AB, because when they kept as BC here, that means they are using here MSB A as input, and here when they are writing AB, C they are using as LSB as input. So for the particular thing, you should apply, you can apply a short technique here. Okay, that is going to be in this manner. Carefully observe. For that one, first, if they are writing MSB here, that is A bar A, you write here and write the numbers like this 0, 1, 2, 3 horizontally like this, la 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 la, 0, 1, 2, 3, 4, 5, 6, 7 like this. Okay, I0, I1, I2, I3. If you are using the input as C, LSB, then you should write the numbers like this 0, 1, vertically 0, 1, 2, 3, 4, 5, 6, 7. It's going to be I0, I1, I2, I3 like that. So now, when they gave the question here, 0, 1, 5, 6, you just round off that 0, 1, 5, 6. Then 0 is rounded means in front of that what is that letter? A bar, that A bar. When in this column both are rounded, then it should be 1. But in this column only 6 rounded. In front of 6 what it is? A. In front of 6 it is, in front of this 6 what it is? A. So that can be written as A. And in this column no one is rounded, so 0. So this is A bar 1, A0, A bar 1, A0. So like that the input should be written. Because when they will give this is the question and they will ask the inputs and you should apply in this the way shortcut technique. Okay. In the same manner here, for this one also 0, 1, given the question 0, 1, 5, 6, 5, 6, then make this one. In this column both are rounded, 1, not rounded 0. In this column 5 rounded, in front of 5 it is a C. C in this column 6 rounded, in front of 6 it is a C bar. So 1, 0, C, C bar, 1, 0, C, C bar, like that. So this is the way. Got it? Yeah, so many students are giving the response. Nutan Kumari, Vijay Chopra, Sachin Tiwari, Rishik, Jaya. Thank you. Yash Gupta, Nitin, right. Ashwin Kumar is asking, sir, when B or C is taken as input, this is B, C is taken as input means we got it. No, this is the thing. When A is taken as input, we got it. No, like this. But you are asking about B as input. Generally, they won't ask because MSB function is the ABC or CAB. Even then, we can handle. See this, how to remember I am saying again. When they are saying that here MSB is taken, then write the numbers like this, la la la, la la la, like this, la la la, la la la, like that. That is ka matlab horizontally, la la la, 0, 1, 2, 3, 4, 5, 6, 7, la la la, la la la, 0, 1, 2, 3, 4, 5, 6, 7. But when they are using the C, LSB, then vertically, la la, like that, 0, 1, 2, 3, 4, 5, 6, 7. That means like this, la la, like that. Sir, but I asked about B, no sir. Array, that also can be handled, my dear, so easily. That with shortcut technique. You are asking all the short techniques today. Yes. When it is B bar B, you should say that is like that. Sir, is this? What is that, sir? Chintu, this is like that. Is like that. Now, then we have to make like this 0, 1, 2, 3, 4, 5, 6, 7. I0, I1, I2, I3. Here 0, 1, 5, 6. Then it's going to be B bar and it is going to be B bar. It is B bar, like that. So it can be done for this particular case, no? This is I0, I1, I2, I3 for that 4 by 1 max when it is of AC. Here we have to write B bar, B bar, B bar, like that. Got it? It is la la la, la la la. It is la la, la la. It is like that. This is the way you can apply the short techniques to remember. Got it? Okay, right. Now, related to the designing also they will ask. For example, they are asking 4 by 16 decoder they want by using 2 by 4 decoder. Then what should be done now here? This 16 by 4 you should divide it. 16 by 4. It's going to be how much it is, tell me? 4, sir. That 4 is taken again, divide this one with this 4. We're going to get, what is that, tell me here? 1, sir. So 4 plus 1 is 5, we'll get it. 5 decode, 5 2 by 4 decoders required. In the same manner, 3 by 8 decoder, they want by using 2 by 4. Again divide like that these two. 8 by 4. 8 by 4. What will get, tell me here? 4. 8 by 4 is nothing but the 2. That 2 by 4 is nothing but 0.5. Or it is 0.5? No, for the case of this one you have to keep 1. This place 1. So 2 plus 1 totally 3. Because आधा pound decoder नहीं होता. We should use the complete decoder for the tough 2 by 4. So that answer is 3 like that. Got it? Right. So there is a question they asked regarding the priority encoder. Priority encoder question they gave like this. For example, in the gate they asked this question. General students used to ask the question related to this. They gave like this the way. This is A, this is B, this is LSB, this is MSB. D3, D2, D1, D0. And they said it's a priority encoder. And given here in the question one interesting thing, given, what is that? D3, the question given like this. D3, D2, D1, D0 for that. They said it should be of 0, 0, 0, 1, 1, 0, 1, 1. It is given in the question in that manner. Nitin, duty cycle also will solve. Please check this one. Focus on the point of present one. Okay, my dear? We'll do that also. Question is given in that manner. And you are asking the expression for B. This expression for B they are asking. Then you should make a table of this one for like this D3, D2, D1, D0. So simple it is. This is AB. When nothing is activated, it won't be the condition undefined. That's why don't care, don't care. When D1, D0 is activated and these are not activated, we will get D0 activated means 1, 1. So we should get here as 1, 1, 1, 1. And they said when it is D1 is activated and these are not activated, whatever it may be, then we should get this is nothing but 1, 0. 1, 0. Because I am writing those things from this given things of the question. And here, when this is not activated, whatever this D2 is activated and D3 is not activated, and below that or whatever it may be, we are going to get the D2 means they said this is 0, 1, 0, 1. And here, when D3 is activated and these are all whatever it may be, then D3 should be of 0, 0, 0, 0. Now they are asking here this expression for B. So here one is there. Let me make the K map of that. So it's going to be D3 bar, D2 bar, D3 bar, D2, D3, D2, D3, D2 bar. D1 bar, D naught bar, D1 bar, D naught, D1, D naught, D1, D naught bar. So this is the way. Here, what is the way? Well, tell me. Here, 1 is there. At that 1 means what are these? These are the things we should take. D3 bar, D2 bar, D1 bar, D naught. D3 bar, D2 bar, D1 bar, D naught. Here it is 1. Carefully check. For this one, we kept here. And for this one, D3 bar, D2. D3 bar, D2 means this one. And we said don't care, don't care, don't care. Don't care means all combinations of above all combinations we should keep as 1 here. Because don't care means D1 bar, D naught bar, D1 bar, D naught, D1, D naught, D1, D naught bar. All will come under the D3 bar, D2. Under D3 bar, D2. And next one, what we were having? This don't care. This don't care is there when all are zeros. That means here this is the way. So now this is going to be D3 bar, D2. And this is going to be D3 bar, D1 bar. This is going to be D3 bar and D1 bar. This is D3 bar, D2. So this is the expression for B, we got it. Check that expression. Yeah, have you got the same, all of you? Yeah, right. Yes, right. In this manner, we got it. Now, related to the flip-flops and all, we are going to get the questions like conversion of flip-flops. Related to that, we are getting the questions. Conversion of flip-flops questions should be handled with the help of characteristic equations. Once we are having the idea about the characteristic equations, just remember those 4 flip-flops characteristic equations. Based on that, those can be solved easily. Check that 4 characteristic equations. Let me write here. We are having for SR flip-flop, Q plus is nothing but S plus R bar Q. For JK flip-flop, JQ bar plus K bar Q. For D flip-flop, it is D only. And for T flip-flop, it is T XOR Q. T bar Q plus TQ bar. So keep these characteristic equations in the mind and solve the questions of the conversion of flip-flops so easily. Let me handle those questions also. For example, we are having they gave here some D flip-flop and here it is Q and here it is Q bar and here it gave XOR gate like this and here they gave some X and they connected like this the way. And they are asking to handle this question. Yes, how to handle this? Carefully observe how to handle this one. No, so simple technique. Here, this expression you write first. This Q came here, and here we got what is that X XOR Q, and this only connect apply to the D, and this expression is the Q plus is what? From this the Q plus we are going to get the D, and here D for that what applied? X exclusive Q, that only will come. So Q plus now we got X exclusive Q. Among all these, which satisfies that T? That's why option is nothing but T flip-flop. Completed. Enough. Got it? Let me ask like that another question also. You should handle that. You should say the answer for that. Okay. Yeah, I'm going to make that question, another question here. Carefully observe that. And you should handle that and you should say the answer, all of you. Okay. Yeah, that question is already asked in the gate. Now I'm going to draw that. Yeah, you understood no this one? Input whatever it may be that apply to the D flip-flop, that only comes at the output as a characteristic equation, and the Q plus is nothing but the D, that is nothing but X exclusive Q. We made it like that. You got it? Now let me check it. Another question. You should say the answer for this. Already I said first only. See that. Let me see how you are going to say this in a simple way. Let me check, my dear. This is the question. Actually, I want some space here, yeah. Okay, I'll do like this. This question, Ramesh, they are going to say easily. Acha, we'll see that. All our students who know the shortcut techniques, they can get all these very easily, my dear. Medici students, easily they can handle all these questions. This is, they said this is Z, and some Z bar like that they gave. In the same manner, here it is going to be Y, and it is Z bar, X, Y, Z, Z bar. This is the way they give the question. Of course, it is they connected from here. Now, they are asking of the conversion of flip-flop, what it is going to be the question. Okay. Now, handle that and tell me. I think the students, they can handle that. Options they gave, what is X, X is what, Y is what, they asked it. So now handle this question. Okay. Yeah, all students you should handle. Vijay, Ashutosh, Sachin, Shreya, all. Okay, right. What is X and what is Y, like that? Okay, all students should handle X and Y. Every student, Rishik, Sachin. Yeah, same way you should handle. Like I said, no, the characteristic equations you should remember. Once you are able to remember those, handling this one is very easy, isn't it? Say the answers. Everyone? Yes. Yeah, getting. This one how you handle? You wrote the equation X XOR Q is the expression that we are applying to the D. So for the D flip-flop, whatever be the input that it goes, it only comes at the output. So simply that is only we are getting at the output. So that expression is this X exclusive Q, and this is matching among these T XOR Q with that. That's why that is T flip-flop. In the same manner, you should do handle now this also. I got a doubt. If it is not D flip-flop, don't worry. That characteristic equation you write, in that you put this input equation and solve that. We'll get it again. If it is not the D flip-flop, whatever it may be the flip-flop, that equation you write from that, In that you put this input there, that solve it and you'll get it. Clear? Yeah, everyone should say. Sanjana, Puneet, both you also you say this one. Got it? All students. Sachin, Shreya, Trishik, Suryash Gupta, Astosh, everyone. Right. Now get this one for example. Here, this is what X bar and it's going to be Z and it's going to be Y, it is Z bar. So that here we are getting X bar Z plus Y Z bar, we got it. Isn't it? Now this is now here Z plus is nothing but what we are getting, tell me. We got X bar Z plus Y Z bar. So compare this one with any of the equation. Yes, now with this I am comparing. Then what we are going to get? Q plus is equal to JQ bar plus K bar Q. So here Z bar is nothing but Q bar, means Y is going to be J. So Y is J and X is K, like that. Got it? Right. Got it, all of you? Many of you got the answer? Yes. Okay, right. Very good. Right. This is about the conversion of flip-flops related to the question. Got it? Now, my dear, based on the counters, generally you will get the questions of like based on ring counters. Johnson's ring counter, ordinary ring counter, which we are having the name of ring counter, and asynchronous counters and synchronous counters. If you know the short techniques of that, we can handle the question so easily. Okay. Now let me ask like that a question here. For example, they gave like this the way. Here JK flip-flops together, input connected like this. JK inputs together connected. That means they are using the T flip-flops. T flip-flops they are using and they are making the connection like this connected. This side the input connection JK and this is Q bar. Like this only, it is also inputs together connected and floating means treated as one, logic one, so that we can say these all are T flip-flops only. Now all these are basically connected from this is the way. And here there is a bubble also they kept. And they considered here from this the connection, and this one is taken and connected here like this. Okay. and they are asking the mod value, and they are also asking whether it is the up counter or down counter also. Now check that and tell me. Rishik said it's a down counter. And someone is saying up counter, someone is saying down counter. Okay. So carefully observe and tell me. So first of all, whether it is the up counter or down counter, how to decide these things, that is having one short technique. I'll say the short technique, carefully understand that. Okay, I'm revealing the short technique also to all of you, how to say whether it is up counter or down counter. Okay, right. So whenever they are giving the question like that, first of all, I just made for your sake initially a diagram here. You first check this one. Based on this, I am going to give the short technique of how to identify whether it is up counter or down counter easily. Then mod value is saying the mod value for the case of the asynchronous counter, it is very easy. First of all, asynchronous counter, how you identified that? Sir, that is because all these flip-flops are not triggered simultaneously. One by one the triggering was taken place. Yes, that's why it is treated as asynchronous counter. That is okay, sir. But whether it is up counter or down counter, that one, how can I say, sir? Yes, that particular thing can be done based on this particular short technique, my dear. Carefully observe. Here, we are connecting like this. Say for example, here I will take the inputs from this side and I'll say that, see that. Here this is the J, K, here Q bar, and this is JK, Q bar. So all these are T flip-flops. As you know, in the case of asynchronous counters, to get the order properly, we are using this. These all are T flip-flops only. J, K, Q bar. Yeah. Here you connect like this here, clock, and this is from this. So these are nothing but asynchronous counters only. Now, here interesting thing is, observe the difference here between these pictures and those pictures, these and those. Here bubbles are there. That means these two are, this is negative triggered one, and this is also negative triggered. And here if you observe, we are connecting these but without any bubble. So we can say these are positive triggered. So these are positive triggered. This is also positive triggered. Sir, these two are negative triggered because you are saying here bubbles are there. Exactly. And here bubbles are not there at the triggering place. That's why these two are positive triggered. Okay, sir. We identified that, sir. But how can I say whether it is the up counter or down counter, sir? Yes. For that, you check it. Here the next flip-flop triggering was done from Q, and here the next flip-flop triggering was done from Q bar. That means for a particular flip-flop, the flip-flop Q seems to be at up, Q bar seems to be at down, no? That's what you said. Very simple point I am saying. For a particular flip-flop, Q will look at up, Q bar will look at it down. It's a simple, no logic in that, no logic in that. A particular flip-flop, any particular flip-flop, you will write Q is there, Q bar is down. So, Q, for this particular circuit, from Q the connection was taken, and for this particular circuit, the Q bar from that connection is taken. And for this, from Q taken, from Q bar it is taken. That means here what I mean to say here is, for negative triggering, here from Q up it is connected, so it is up counter. And for the negative triggering, from Q bar, from down it is taken, that means it is down counter. And for this positive triggering, from up it is connected, from Q it is connected, that means it is nothing but down counter. And from Q bar it is taken, that means it is nothing but, or up connected it is down counter, and down connected it is up counter. So now we will rhythmic way all these things we will say. Now our students, you can also write that in the form of message, because you know that technique. Negative triggering, up connected up counter, down connected down counter. Positive triggering, up connected down counter, down connected up counter. Say all of you again with me. Negative triggering, up connected up counter, down connected down counter. Positive triggering, up connected down counter, down connected up counter. Say all of you. Got it? Yeah. Sir, this is a short technique. Yes, my dear. Negative triggering, up connected up counter, down connected down counter. Positive triggering, up connected down counter, down connected up counter. Now, based on this technique, come to the question here, what they asked here. Now tell me, this one, based on that short technique, now tell me whether it is up counter or down counter. Sorry, it is, yeah, tell me. That is the negative triggering, yes. And up connecteds are, yes, that means it is up counter. Yeah, up counter. Because it is negative triggering. And Q, up connected. So it's going to be up counter. From the Q bar, if it is connected, it's going to be down counter. Now, mod value, how to say that? From the logic gate, for the logic gate, from which flip-flops the connection is there? A, B, C, D flip-flops in that. From A, the connection is there. From the A, connection is there. So keep one here. And here, from C, connection is there. Keep one here. And other places 0. That's enough. So 1, 0, 1, 0. It is going to be 10. So it is mod 10 up counter. Mod 10 up counter. First triggered flip-flop is LSB, my dear. If the triggering was taken from this side, right side, the code should be reversed and answer should be taken. Remember that. Here the triggering is from this right side. That's why the code as it is, the mod value is said. If the triggering was done from this side, left side, the code should be reversed and you should say the answer. Okay? Right. Got it? Based on this one very interesting question they asked one time, and you should say the answer for that, all of you. Okay, I'm going to draw that. You should make that answer. Okay, right. My dear, here one very important point is there, very important point which we missing here. If it is NAND gate, here the bubble should be there. If it is AND gate, it should be without bubble. That means for the NAND gate, it should be clear bar, we should get it all. Okay, this is very important. Okay, if it is AND gate, then only without bubble. If it is NAND gate, bubble should be there, clear bar. That is very important. Now the question here, it is given like this. This is Q bar, J K, Q bar, Q bar like that. They gave like this. And they took the connection from this and also from this. So two input gate. What should be this gate? They give the options here. A, and B, NOR, or AND. Okay. And here they gave bubble. So what should be this one? And they said that it should be mod 6. Given it is mod 6. And what the gate it should be, they asked. For such type of questions, don't think much. There is a simple short technique I am going to say to you. Any question they gave, what the gate it should be, and they gave some connections like that for the case of asynchronous counter. Sir, is it asynchronous counter? Yes, my dear, asynchronous only. Okay, they made like this the way connection. Okay, and they asked the question. Now, can you try that? Yeah, for this one, the short technique I am saying, remember that. Carefully observe. You say along with me. NAND, NOR and OR. What you are saying? Yes, like this. NAND, NOR and OR. Next. Q bar, Q bar. Next. Clear bar, clear bar. See, NAND, NOR and OR, Q bar, clear bar, clear bar. This is the way, the short technique. Again, NAND, NOR and OR, Q bar, clear bar, clear bar. This is the short technique. So how to do that, how to handle that? You now handle it and tell me. Yeah. Now corrections from where we got, we had to check that. From Q bar we got, from Q bar we got. So from Q bars we got to this circuit. And where it went, here this is the thing, this is the thing. That means they went to clear bar, clear bar, clear bar. That means connections are taken from Q bar and went to the clear bar. Now Q bar, clear bar, where they will match? Are Q bar, clear bar, OR gates are? Yes, answer is option C, OR gate. Very simple, no need to think anything. It's a time of examination time, very less time. Just apply the short techniques of these. Remember, all short techniques I am revealing. Just apply these and get it. NAND NOR and OR, QQ bar, clear bar, clear, clear, clear bar. Here the connections are we got from Q bar and went to clear bar. Q bar, clear bar are matching to the OR gate. That's why OR is the answer. Have you enjoyed the shortcuts all? Please give the response to me. Have you enjoyed all of you? Nutin Kumari, thank you, sir. Okay, thank you for the response. Yeah. Yeah, got it. So for the asynchronous counter, any critical question also given in this manner, no need to think. Simply from the connections where we got Q bar and Q bar, where they went clear bar, where they went, tell me, clear bar. So that answer Q bar, clear bar in this shortcut matching to the OR gate. So OR is the answer. Jaya, Suman, Vijay Chopra, Nutan Kumari, thank you for the response. Ashish, Shishik, Sachin. Now, about the asynchronous counters like this, in the same manner for the case of synchronous counters, they will ask the mod value. Then how to handle that, those also. Let me conclude this one. The short technique is, first whether it is the up counter or down counter can be decided by this way. That is negative triggering up connected up counter. That means from Q if it is connected, it is the up counter. For the next triggering, if it is from Q bar, it is connected, it is the down counter. Like that for the positive triggering, if it is connection was taken from Q, that means from up, it will be the down counter. If the connection was taken from Q bar, that means from the down, it is going to be the up counter. The short technique I explained here now for you. Able to remember that? Yes, this one. So negative triggering up connected up counter, down connected down counter. Positive triggering up connected down counter, down connected up counter. So that technique wise only we applied here also. So that negative triggering up Q from that connected up counter. Okay. So and such type of critical questions also can be handled. What gate it should be for the mod 6 of the given counter they asked. It is generally difficult to handle for the so many people, but our ADG students can handle very easily with the shortcut techniques because we used to discuss all such type of shortcut techniques in the classroom. Right. Now come to the next one. Here. Now we will discuss about the synchronous counters if they ask you the questions how to handle. Now see, for example, there is a question already I drew it on the board because to save the time here. And this is synchronous counter. How can we say that? because all the flip-flops connected from the same clock generator, so that it is a synchronous counter. Simply by observing, watching it, we can say it is a synchronous counter. No? Yes, sir. Now, in order to say about the mod value, 3 steps you should follow there. Those 3 steps are: number 1, write the inputs and outputs in the form of table. Sir, what you said? Write the inputs and outputs in the form of table. Like here, J1, K1, J0, K0, Q1, Q0. And this is the clock. So all the inputs J1, K1, J0, K0, the inputs of the flip-flops written here, and outputs Q1, Q0 also written there. Okay, we got it. So that's the first step. Now second step. First step is write the inputs and outputs in the form of table. Second step, write the corresponding connections on their head. On their head, corresponding connections. The corresponding connections means arrange into J1 from where it is taken. J1 is taken from Q0 bar. This Q0 bar, no. J1 is taken from Q0 bar. Okay, sir. And K1 is taken also from Q0 bar. Okay, sir. And J0 is taken from Q1 bar. J0 is taken from Q1 bar. And K0 is given always 1. So this is the thing. Once we wrote those input connections from where we got it, problem almost half over. Oh, sir. Yeah, we will do that. Now, initially they haven't mentioned here and here. So they haven't mentioned anything initially. So we can keep that anything. Like I consider those are by default 0, 0. By default 0, 0. And make a horizontal line. Sir, 0, 0. Yeah, initially they haven't mentioned, no. So that by default any state you can consider. Sir, then why it is 0, 0 only? RH into, you consider 1, 1 or 1, 0 or 0, 1, whatever it may be, my dear. It's your decide. If default state is given, that only should write there. Okay. Now once we wrote like that, now we have to check this. Carefully observe. This is Q0 bar, 0 bar, it's going to be 1. Q0 bar, 0 bar, it's going to be 1. Q1 bar, 0 bar, it is going to be 1. And this is 1. So clock applied here, 1 clock. 1, 1 is applied to the JK flip-flop. You know 1, 1 is nothing but a toggle condition. So previous 0 will change to 1. And here also 1, 1 is applied to the JK, J0, K0 flip-flop. That means it is also the toggle condition. So previous 0 is going to be changed as 1. Like that we got it. Check that properly. Okay. In the same manner, next apply these things. What we got here? 1, 1. Q0 bar. Q0 is 1. 1 bar is 0. K1 is Q0 bar. 1. 1 bar is 0. Q1 bar. 1 bar is 0. This is 1. So after second pulse, 0, 0 for the JK flip-flop means no change. No change means 1 will be as it is 1 only. 0, 1 means it is a reset. Reset means it is nothing but the 0. So 0, 0, no change. So 1 will be 1. 0, 1 is the reset. That's why the 0 we got here. Next again we should apply these things here. Yeah. Q0 bar, 0 bar, it is 1. Q0 bar, 0 bar, it is 1. And Q1 bar, 1 bar, it is 0. And here it is 1. So here after third pulse, 1, 1 means what? Toggle. Toggle means 1 will change to 0. 0, 1 means what? Reset. So it's going to be 0. Okay, that means the 0, 0 again repeated here. So unrepeated states 3. That means it's going to be mod 3 counter. Mod 3 counter, we got it. It's a mod 3 counter. Got it all of you? because 3 states we got unrepeatedly. So it's a mod 3 count. Now in this case of the counters, they used to ask the duty cycle also sometimes. So duty cycle in the sense how to make it, carefully observe this one. For example, at the Q0 they asked the duty cycle. Here if they ask the duty cycle, what is the duty cycle? Duty cycle is nothing but T on by T on plus T on by T on plus T off into 100%. Then here, what is Q0 here? You watch this, you observe this one. This is Q0, we got this 0, 1, 0. So, here it is going to be 0, 1, 0. Again, 0, 1, 0. So, this is the way we are getting waveform. This is the waveform we are getting 0, 1, 0, 0, 1, 0 like that. So, how many times it is on? Sir, one time it is on. So, it is going to be TC. T on is 1 TC. T off is 2 TC into 100. That means it's going to be what? TC by 3 TC. TC is cancelled, it is 100. So that is 1 by 3 into 100. Got it, all of you? So it's going to be 33%. Now in the same manner, if they ask the duty cycle, if they are asking the duty cycle at Q1, it is the duty cycle at Q0, duty cycle at Q0. Now like that the duty cycle at Q1, you tell me, at Q1 how much it is, tell me, you calculate and tell me now. Yeah, the waveform here is what it is, 0, 1, 1, it is 0, 1 and 1 like that. Again 0, 1, 1. 0, 1, 1, 0, 1, 1 like that we got it. So then how we can make this one now? That is T on by T on plus T off. On how many times? 2. So 2 TC by 2 TC off how many times? 1 time. TC into 100. It's going to be 2 by 3 into 100. That's going to be 66.6%. Check it. Yeah, Kalpesh, Shreya, Suman, Vijay Chopra. Thank you, Notan Kumari, everyone. Thank you. All of you have got the answer same. Deyanshu, yeah, I got the answer, all of you. Right. Yeah, Sai right. Yeah, have you got it? Yeah, Puneet, you got here 66.6. Sanjana, you got here 33.3%. No? Yes, right. Kalpesh, Shreyash, yes, right. 60, you are just mentioning 66 and 33 like that, but where it is you also mentioned that. Here it is at Q0 we got like that 33 and at Q1 we got 66. Okay, right. Right, this is the way you can handle a synchronous counter related questions also, right? Now based on this, even the designing questions also you can expect. Yeah, let us handle the designing question also for the synchronous counter. For example, they gave a question here. D1, this is Q1, this is Q1 bar. And this is actually D0, Q0, Q0 bar. And they are taking the connection from the same clock, that means it is a synchronous counter. Now they are asking the inputs here, what will be the D0 and what will be the D1, and they want the given wanted sequence is for Q1, Q0, the sequence they want is 0, 0, 0, 1, 1, 1, 1, 0. So like that the sequence. So they are asking for the designing what we are going to get there. Okay. Yeah. Now to do that, the procedure is going to be like this. You should write present state, next state, this Q1, Q0, Q1 plus, Q0 plus, D0, and this is D1, and the given sequence is 0, 1, 3, 2 they gave 0, 0, 0, 1, 1, 1, 1, 0. Sir, why 3, 2 you took? Array, they gave like that only, no? 0, this is 1, this is 3, this is 2. This is the wanted given sequence. So these are the present state. Its next state is this 0, 1 only comes here, and this 1, 1 here, this 1, 0 here. For this 1, 0, next state will be 0, 0. So it's going to be now here 0 to 0 plus 1 to 1, like this we should take from the excitation table of D flip-flop. Q plus 0, 0, 0, 1, 1, 0, 1, 1. D flip-flop excitation table is going to be 0 1 0 1. So 0 to 1, 0 to 1, it's going to be 1, 1 to 1, it is going to be 1, 1 to 0, it's going to be 0, it's going to be 0 here. Like that. D1. D1 is going to be from Q1 to Q1 plus we should take. From Q1 to Q1 plus. That is 0 to 0. Like that it's going to be 0. 0 to 1. 0 to 0 it's going to be 0. 0 to 1. Here 1 and here 1. Here it is 0. So from this excitation table we are filling that. Now we are going to get the K map. Very simply also you can do that. So it's going to be Q1 bar Q1, Q0 bar Q0. So it's going to be D naught is nothing but this is the one, and here Q1 bar Q0 here. So it's going to be D naught is nothing but Q1 bar you will get. It's Q1 bar Q1, Q0 bar Q0, and D1 is nothing but it's going to be Q1 bar Q0 here 1, and it here Q1 Q0 here it is 1. So it's going to be D1 is nothing but Q0. Have you got same all of you? So those inputs are calculated. Check it all of you. Give the response to me. Have you got the same? D1 is Q0, D0 is Q1 bar. Have you got it? Yeah, right. So for this the procedure is present state, next state, and based on that the excitation table you should get this, and by the simplification we are going to get the inputs. Got it? Right. Yeah. Now in the case of asynchronous and synchronous counters, the propagation delay they are going to ask. For the case of asynchronous counter, it is going to be n into TP of each flip-flop. But in the case of synchronous counter, it is going to be only TP. You should remember that also. And all other things are like Johnson's counter. How to identify that? When the flip-flops are there like this, in the case of Johnson's flip-flops, Johnson's counter, flip-flops are taken as D flip-flops. This is Q bar. If the connection was taken from this complementary output like that, it's going to be Johnson's counter, or it is also having the name of twisted ring counter. If the connection is taken from Q, then it is going to be like all these are D flip-flops. Remember, sometimes they can keep like this the J, K, and between them the NOT gate. It is also nothing but the D flip-flop only. Okay. So this is this is the Q, this is Q bar. No, if the connection is taken directly from Q, it's going to be ring counter. And the mod value for this one is going to be 2 into n is the mod value. And here the mod value is only n. And here 2n means where n is the number of flip-flops. You should remember, based on these also you can expect the questions. Vijay Chopra is asking, sir, please explain present to next state again. The Chintu, so easy, my dear. This is the present state 0, 0. Its next state is what? 0, 1. That 0, 1 only I wrote here. And for the 0, 1, next state is what? 1, 1. So that 1, 1 I wrote here. So like that I wrote. Next, 0 to 1. 0 to 1. What will get? 1. That I wrote here as 1. Next, 1 to 1. 1 to 1. What will be that? 1. That's why I wrote 1 here. 1 to 0. 1 to 0. What it will be? 0. So 1 to 0. I wrote 0. So 0 to 0. 0 to 0. 0. That 0 I wrote here. Like that we had to make it. Okay. Yeah, in this, someone is asking about the lockout condition. Let me say that point also here. For example, you started here. Carefully observe, my dear. Very interesting thing here. If you started here, like 0, 0, 1, 1, 1, 0, you started with 0, 1, for example. Sir, 0, 1 is not there in the sequence now. Yes, when it is not there in the sequence, if by default you started that particular state which is not there in the sequence, what may happen? We will check that. Based on that, I'll discuss something here which is related to the question you are asking in the message to me. So 0, 1. Now that 0, 1 you apply here Q naught bar, 1 bar, 0. Q naught bar, 1 bar, 0. Q1 bar, 0 bar, 1. 1 is 1 here. So 0, 0 means what will get? Tell me here. 0, 0 means no change. So 0 will be 0. 1, 1 means what? Toggle. So 1 will be 0. Array, if you start with 0, 1, we got again 0, 0. 0, 0 we got means next we will get 1, 1. 1, 1 means next we will get 1, 0. 1, 0 means next 0, 0. Sir, how you wrote this one this much fast? Array, already we did know. 0, 0 once you get, next will be 1, 1, next will be 1, 0, next will be 0, 0. So, if you consider the initial state as 0, 1, which is not there in the sequence we considered, for example. Sir, but how do you know that it is not there in the sequence? For example, my dear, sometimes 0, 0 also won't be there. So, the situation here is, if you consider a state which is not there in the sequence and we started, what happened in this case? Immediately it jumped to the 0, 0 and again like this, and the 0, 0 is not repeated. So, it is going to be mod 3 only again. Why mod 3, sir? 0, 1 is also there, no? No. In the cycle, what they came, in the cycle, what the states we got, based on that only we should say the mod value. That means 0, 0, 1, 1, 1, 0 only in the cycle we got again. Even though we started with 0, 1, it doesn't came back in the sequence again. That's why we should not consider that in the mod value to say. That is the thing. Now, the point is, with the 0, 1, again it came back to our original sequence. That means it is said to be as self-corrected counter. Self-corrected counter. It is not lockout condition. It is not lockout. It is a self-corrected counter. Because we started with some other state, even though it went to the, even though that particular 0, 1 is not came, it again came to our original sequence and we got it. That means अपने आप वो correct कर लिया, वापस it is not went to the unwanted state, so it is in the desired sequence only it came back. Once it came back to our desired sequence, then we will say that it is the not a lockout condition, it is a self-corrected. If it is in that unwanted state only remained, then we will say it is a lockout condition. Got it? Yeah, check that all of you. Yeah. So this is a way, my dear, generally any of the counters, these much of counters like Johnson's counter, ring counter, asynchronous counter, synchronous counter, all are covered in our discussion now. That too with the simple techniques only. Whatever be the question they gave, just apply these techniques and get it that. So easily you can handle that. Got it? And as far as this particular ADC DAC is concerned, in that you should follow, generally you'll get in the ADC DAC based on the resolution only, maximum questions. And the resolution, which is also known as a step size, this related questions only in the objective you can get, that is resolution or step size is nothing but V full scale voltage by V reference by 2 power n minus 1. That is nothing but full scale voltage by number of steps. So based on that we can do that. So maximum questions of that will be based on the simple formula only in the ADC DAC like that. Okay, right. In the case of logic families, I said already, when you are having like this the way, like this the series wise connection for NMOS or NPN, or in CMOS also you should focus on NMOS. So series is nothing but the AND operation, and if you are having like this the way the connection in this manner, parallel, it's going to be the OR operation, my dear. Okay, so series wise and parallel wise is the OR operation. So based on this, the logic families related question, anything you can handle. And in addition to this one, you just follow the table of fan out, noise margin, these values for the different logic families. Based on that, one objective question you can get it. Okay, these all techniques we discussed in our medicine classrooms. You just focus on those. Okay, so anyway, my dear, we discussed all such type of questions like with short techniques where we can handle the questions within 1 or 2 seconds only. Implement these logic techniques and solve those. Okay, right. Yeah, logic families का वो table fan out, noise margin, propagation delay related, that means speed, which is having more speed. Though just before going to the exam, before that day, just remember, just write that, because those are the values. No, there is no shortcut for that. No, those are values like that. For such type of things, you can say the shortcut like negative triggering up connected, up counter, down connected, down counter. Positive triggering up connected, down counter, down connected, up counter, like that. Got it? Right. Yeah, dear students, anyway, we covered all these things with the shortcut techniques and all. You please implement these and do it. And all the best to all of you. God bless you. Thank you, one and all.